Disk management. In this disk management discussion, we'll start off with a discussion of basic and dynamic disks. Basic disks are probably what you've been accustomed to working with if you're working with PC-based computers from years past. This goes all the way back to DOS. It's just that Microsoft now calls them basic disks, and the only reason why they need a name for them is to compare them to the new dynamic disks, which first came out in Windows 2000 and are now also in Windows Server 2003. With a basic disk, you can create a partition. You can create primary, extended, or logical drives in extended partitions. And we'll look at all of that as we go. And then you can also create volumes in a dynamic disk. So that's the differentiation between those two. Basic disks work with partitions, dynamic disks work with volumes. And then we'll look at how to initialize disks as well. This is something for the most part that's automatic, but you'll use a wizard to put some identifiable information on those disks for you, and that's very useful, especially, for example, if you want to transport the disks to another server at a later time. And then we'll look at creating logical volumes. A logical volume really is any unit of storage. Could be a partition, or it could be a volume, could be a logical drive, could be a spanned volume, all of those kinds of things we'll be looking at here as we go along. Well, I remember my first hard drive. I think it was a 20 megabyte Seagate back in 1988. It was an ST225 or something like that. And at the time I bought it, 20 megabytes seemed gigantic. All my friends said, "James, you're a fool. You'll never use 20 megabytes. Well, then a little operating system known as Windows came along, and guess what? Yeah. Opened up a whole new world of storage requirements, and I chewed up that 20 megabytes pretty quick. Well, regardless of the kind of storage you have, because nowadays, of course, you can get to 120 gigabytes, 200 gigabytes, and even more, you need to know how to manage that disk storage. And one of the first decisions you'll need to make is what kind of disk you want to use. You can use either a basic disk or a dynamic disk. Now, basic and dynamic disks are new terms with Windows Server 2003 and with Windows 2000. Prior to these operating systems, we never differentiated basic and dynamic. That's really a term that Microsoft has put on disks. Basically, a basic disk is the same kind of disk we've had ever since the days of DOS, where if you used DOS in the past, you might have used something called fdisk, which is a DOS command line utility that you use to create partitions. And that's the main distinctive between a basic disk and a dynamic disk. A basic disk works with partitions. A dynamic disk works with volumes. Now, regardless of whether you use basic disks with partitions or dynamic disks with volumes, we call the storage area for the partitions or volumes a logical volume. Now, there are a number of ways of coming up with a logical volume. If you use basic disks with partitions, you can create up to 4 primary partitions. And the purpose of a primary partition is that it can be marked active, which tells the BIOS that it is a startable partition that can launch an operating system. Now, why would you have 4 primary partitions? Well, you might do that in an old multi-boot scenario where you have multiple operating systems that you want to boot on the same machine. Each one will require its own primary partition. One thing you should also keep in mind is that if you do this kind of a scenario where you have multi-boot going on, always start with the oldest operating system, in this case Windows 98, and move on progressively in your installations to the newer operating systems. That way, these subsequent operating systems, for example, which all use a boot.ini file, will subsequently, boot.ini, will all modify the boot.ini file, which is kind of a boot menu that you will see when the system starts up, and it will allow you to select from all of these operating systems. Now, you could install a new operating system. You could have installed Windows Server 2003 first and then gone back to Windows 98, but it requires a lot of reverse engineering and quite a lot of manipulating of the partitions in order to get them to work right. Now, you don't see this kind of a scenario very much anymore where we have this multi-boot because there are third-party products like VMware or Microsoft's own Virtual PC, which is a new product at the time of this recording, and they allow you to run multiple operating systems within one booted operating system. Now, I won't go into a lot of detail with that, but just believe me, if you need to run multiple operating systems, it's best to look into those kinds of products, which are usually only, between $130 to $250. Now, let me also point out that just because you can use up to 4 primary partitions doesn't mean you have to on a basic disk. I mean, I could create 3 primary partitions and then have an extended partition, which I'll discuss shortly here, which contains logical drives. Let's go ahead and take a look at extended partitions, where in this case, I've created a single primary partition, and I've created an extended partition represented by the E down here for the other portions of the drive. The purpose of an extended partition is really nothing on its own. Its only purpose in life is so that you can create logical drives. Logical drives will each have a drive letter within the extended partition. And they can also be mounted volumes, which I'll discuss a little bit later. But typically, they will, most of the time, have a drive letter. So, for example, this might be drive letter C, and then my logical drives would be drive letter D, E, F, and G, and so forth. Now, let's also discuss why I would use this kind of a scenario. And by the way, this will be more commonly what you'll see on servers and workstations, where you'll have a primary partition here and separation of the data elsewhere. For example, many people recommend that you take your operating system and your applications and you separate those out. I'm not so sure that I recommend that necessarily, but if you want to go ahead and do it, fine. However, in terms of your data, you usually should keep that on a separate partition. Well, the reason why I would want to do that with either apps and or data is because if there's corruption, let's say I've got a Visual Basic script which can have malicious code in it at times if you have a hacker that's modified it appropriately, then it might corrupt applications and maybe even this whole partition here. Well, if this gets corrupt and messed up pretty badly, it only affects this one partition and not my operating system. So at least that can continue to operate while I wipe out this partition and recreate it and install my applications again. Likewise with data, if I have a virus that infects data here, maybe that somebody downloaded and applied to this partition, well, I don't want it to corrupt my operating system or vice versa here. So by separating the data out, I can help to abstract it and protect my operating system and my data. Another purpose for this is if I keep my data on a separate partition from my operating system, for example, then fragmentation will not be as much of an issue. We'll talk about fragmentation later also as well. However, fragmentation is where you'll have a file that gets broken up into pieces that are non-contiguous throughout the hard drive, and they eventually will slow down performance. Well, by separating the data, which changes frequently, from the operating system, which is normally more static, I will help to improve performance in many cases. Now let me also make a couple of other recommendations. You can take these or leave it, just whichever you like. I myself will often create a partition for images and for backup. The images will be used to create images from third-party products such as Ghost. And Ghost is the predominant manufacturer out there of imaging software, which will take a snapshot, if you will, of an entire partition like my operating system, store it in a single file, and I'll put that maybe on my images partition down here. And then if my operating system ever gets corrupted pretty badly and I can't repair it in a timely fashion, then I can restore the entire partition from the image file that's stored down here in just a matter of minutes. And I don't necessarily endorse Ghost, it's just that it's the predominant product out there. You can learn more about it if you like at www.norton.com. I'll also, at times, if I have plenty of hard drive space, and you will with today's large hard drives in many cases, create a backup partition which contains just backups, file-based backups of my data most of the time. And I simply do this because hard drive storage is fast and it's more convenient than having to mess around with tapes. It's also less expensive in most cases nowadays. Now with dynamic disks, I can create volumes. Now the first of these 5 types that I can choose from is a simple volume, and it's most equivalent to a basic partition on a basic disk. And this is a single unit of storage. Now one advantage of a simple volume over a basic disk or a basic partition is that I can extend a simple volume so that if I start to run out of hard drive space, and yet I have additional free space on the same physical disk that hasn't been used for anything yet, then I can extend that simple volume over to my free space over here and thereby increase the size of my storage here. I can also use a spanned volume, especially if I have large storage requirements. With a spanned volume, I can use up to 32 disks. And the way this works is I have the first disk here. When it fills up, any additional data gets stored on disk 2. When it fills up, any additional data gets stored on disk 3, and so on. Now, one thing to keep in mind here is that both simple volumes and spanned volumes are not fault tolerant. Fault tolerant means if one disk fails, then I still have another disk, one or more remaining disks, where I can still recover the data. With the spanned volume, however, there's no fault tolerance, so that if disk 3, for example, makes horrible grinding noises, which you'll see in a bad hard disk, that's what you'll hear many times, horrible grinding noises where the heads are rubbing up against the platters and it sounds really bad and it's smoking or something like that. If that disk goes bad, can I just replace it and get my data back? No. If that disk goes down, all of the data on the remaining disks is also unavailable, and you basically lose the whole thing. Which also means that, because in this case I'm using 4 disks, I've increased by a factor of 4 the possibility of a physical disk failure. So spanned volumes are primarily useful for a large library of read-only data, or data that you have frequently backed up and where you have very reliable backups and where you have a high tolerance for loss. Now, because of the increased possibility of failure with one of these drives failing, you cannot put the Windows Server 2003 operating system on a spanned volume. Now, let me also take a brief tangent here to talk about the system volume and the boot volume. The system volume is the volume where the boot files are located. The boot volume is the volume where the system files are located. I know that's extremely backwards, but that's the way it is. Let me show you in the file system what I'm talking about. My system volume in this case is drive C. How do I know that? Because it has my boot files, boot INI, which if you take a look at it, identifies which partitions are available to load the operating system here. We also have the NT loader and NT detect. These are my boot files, and yet the volume that they're on will be identified as the system volume. Now, the operating system files, in other words, the system files, are in this case located in the Windows directory, and that's typical. And whichever drive contains the system files is known as the boot volume. So, the system volume contains the boot files, the boot volume contains the system files. I know it's backwards, that's the way it is, you'll have to know that. Now let's talk also about a striped volume. A striped volume uses multiple disks, and again, you can use up to 32 disks in a striped volume as well. The advantage of a striped volume is, which is also known as RAID 0, by the way, the advantage here is that it's also extremely fast. A spanned volume, which looks similar, uses one disk at a time until it fills up and then it moves on to the next one. A striped volume uses all disks at one time, depending on the interface. Especially with SCSI, for example, which is usually what you'll see in a server. Then if I have 4 disks here, 1, 2, 3, 4, oops, that's supposed to be a 4, then if I write a large file to my hard drive, these will all be identified by a single drive letter, for example. Let's say that's drive F. Then it actually writes pieces of that file to each one of these drives simultaneously. Therefore, I don't get the performance of one disk like I would have with a spanned volume or a simple volume. I get the performance of one disk times 4. Now, unlike some of these other solutions we'll look at shortly here, a striped volume is also not fault tolerant. So, even though I get great performance out of this, if I lose disk 2, again, I lose the whole thing and I'm pretty much done for. However, that again might be an acceptable risk if you have regular backups and if you have an application where you need those kind of striped volumes. This might be the case on, for example, certain workstations where you use large AutoCAD files, large graphic files, large movie files, that kind of thing, where you need to get extremely high throughput with your disk I/O or input-output. By the way, also I mentioned RAID here a moment ago. Again, we'll cover that shortly with some more detail. But RAID stands for Redundant Array of Independent, or sometimes they'll also call this inexpensive disks. And the next kind of a RAID that is available is a mirrored volume, which is a RAID 1 volume. This is a fault-tolerant volume, and it uses only 2 disks. And with this scenario, we'll have 2 disks. Here's my first disk in the machine, and here's my second disk. Now, what happens is when I write a file to this machine, it writes the same file to this disk and this disk simultaneously. There are a couple of ways you can do this, by the way. You can attach both of these drives to a single controller here. And I'm going to try to draw a controller. I'm not sure I'm going to do a very good job of it here. But there's my disk controller, my SCSI controller, for example. Now, this would be a simplex configuration. The meaning of this is, if this controller here, this SCSI controller goes down, guess what? I lose both of these disks as well. Another thing I could do, however, is to have 2 disk controllers, where I have this disk controller, for example, that attaches to this drive, and this controller attaches to this drive. That way, if this one goes down, I still have a remaining SCSI controller in this duplex configuration that will still be able to access one of the disks, still be able to perform and give me access to my data. Now, the final kind of volume we can use is a striped volume with parity, or also known as a RAID 5 volume. With this, let's say I have 1, 2, 3 disks, and we get some of the benefits of a striped volume with this, in that when a user writes data to these disks, it writes to disk 1, it writes to disk 2 simultaneously. And then while it's doing that, it also uses processor utilization on the server, which can be a performance problem, by the way, if you have a lot of writes. It uses processor utilization on the server to write parity information, which is checksum information, on one of the other disks. And then it will rotate this, by the way. In this write, disk 3 got the parity information, or the checksum information. The next write, disk 2 might get that checksum information. Next write, disk 1, and so forth. Now, the purpose of this for example, is that if disk 2 goes down, disk 3 can reconstruct whatever data was supposed to be on disk 2 with this checksum information, and the data continues to be available. And then when I replace disk 2 with a new disk, it'll reconstruct all the data on disk 2, and I get my additional performance of being able to read and write to 2 disks simultaneously again. Now I can also go again up to 32 disks with this configuration as well. Now let me also point out that with these bottom 3 types of volumes, I'm limited in my disk space according to the amount of total space available on the smallest member of any of these types of volumes. So for example, with a mirrored volume, if I had 20 gigabytes on this drive and 40 gigabytes on this drive, well, I couldn't use all 40 gigabytes for the mirror, I could only use 20. Likewise with this, if I had 20, 20, and then 30 and 40 gigabytes on these 4 disks, then my limitation would be 20 on each one of these disks all the way through. And the same would be true of the striped with parity as well. Now let's go ahead and compare basic disks with dynamic disks. First of all, a basic disk is pretty much an industry standard, so that a primary partition, for example, could be read by Unix, could be read by Linux, could be read by Novell NetWare. You can read a basic primary partition or even a logical drive in an extended partition using most operating systems. It's also the default partition type that you'll have, the default disk that you'll have when you install Windows Server 2003. And there's no reason to change that as long as you're using a single drive, because only when you use multiple drives do dynamic disks really have any relevance. Also, you have to use basic disks on laptop hard drives or on removable storage. Now, as I move to dynamic disks, let me first of all point out that although the word dynamic sounds like, powerful or something like that, it's no more powerful than a basic disk, especially if I have a single disk involved. I mean, if a disk spins at 10,000 RPM as a basic disk, it'll spin just as fast as a dynamic disk. It's only until I get into the RAID solutions where I get a performance benefit. Now, one thing that I will have with the dynamic disk is the logical disk manager, which is a database of information about the disks that are in that group. And it makes it very easy to transfer those disks to another computer. So for example, if my existing Windows Server 2003 server has a problem, but the disks are still okay, I can transport them to another Windows Server 2003 server and just import them and continue on business as usual with very little downtime. Also, we have unlimited volumes, whereas with a basic disk, we have four primary partitions or up to 3 primary partitions and 1 extended partition with logical disks. Here, I don't have that limitation with 4 or 3 or any of that kind of stuff. I just have unlimited volumes that I can create, and very flexible volumes as well, because I have RAID 0, RAID 1, and RAID 5 types of volumes that I can create. Now that enough talk about partitions and volumes and dynamic and basic disks and all of that, let's go ahead and do something with this. Now, in order for me to do this, let me give you a little background on how I'm going to be working with a lot of the servers that you'll see in this whole series. Down here you'll see DC Nugget 3, for example, remote desktop is what we looked at there. And when I clicked on it, it brought this up. What this is remote desktop. See, I have another server called DC Nugget 3. Most of my actions, and I'm minimizing that, most of my actions performed on this desktop where I'm logged on as trainer, which is an administrator account. Most of those are performed on DC Nugget 1, and that's pretty much our primary server that we use for most of our functions. But if I need to connect to another computer, I'll use something called remote desktop connection, and that's found on all programs, accessories, communications, and then remote desktop connection. When you click on it, it opens up an interface like this, and I click on connect to another computer. I've already done that, and I'm connected now to DC Nugget 3, which as soon as I click on it, you see it right here. Now, we'll be discussing this quite a lot more, especially in terms of terminal services, which is very similar to what I'm doing here, later on in this series. But the reason why I'm telling you about it right now is so that you can get an idea of what this thing is up here and why I'm connecting to this computer remotely. For the time being, just take it by faith that we're connecting to a computer remotely and we'll be performing administrative functions on that computer. All right. Now, without any further delay with that, let's go ahead and work with some of our disk management functions. That can primarily be done by right-clicking on my computer and choosing Manage, or I could go to Run, or a command prompt, either one, and type in disks1.wmv. This opens up an MMC console for us, And MMC is a Microsoft Management Console that will allow me to work with whatever function I need here. I'm going to cancel this because I'll come back to it in just a moment, and I'll explain that to you in a moment here. Now, this opens up the Disk Management Console like I just mentioned. Probably the more common way of accessing this will be through the Start menu by right-clicking on my computer, and then choosing Manage, which opens up not only disk management, but a variety of other functions as well. Now that I've got that open, I'll simply click on Disk Management, where again I'll get this wizard. Now let me point out what happens with this. I have 3 SCSI disks attached to a SCSI controller here, and when I open them, when I access them for the first time using this disk management item that we see back here in the background, it needs to initialize those disks. What happens during initialization? Well, it allows the operating system to write a master boot record or a globally unique identifier partition table or a GUID partition table to the disk. A GUID partition table is only relevant to the Windows Server 2003 family where it's the 64-bit version of the Windows Server 2003. And you'll only see that on Itanium computers, which is a special type of processor that's a 64-bit processor available from Intel. For our purposes, we won't be using the 64-bit version, so we'll just be using master boot records. It'll also write a disk signature to the disk, which is a unique identifier to that disk, and an end-of-sector marker, which is also known as a signature word. Now, once I go through this wizard to do all of that, we don't really touch that again, and it's really not relative to anything else that we'll do, so I'll just quickly go through the wizard by clicking on Next, and then it'll ask me which disks I want to initialize so that the logical disk manager can access it. And it does have to be initialized in order for us to be able to create partitions and the like. Now I've got those 3 disks available there, so I'll go ahead and click on Next. And then it asks me if I want to convert any of these to dynamic disks. At this point I do not. I will convert them manually a little bit later on using a different method. So I'll click on Next and Finish, and that's pretty much all there is to it. And now you see I have 3 relatively small disks down here, 10 gigabyte disks 1, 2, and 3. Notice also that the logical disk manager, which is what allows all of this to be visible to us, uses ordinal numbering, which means that you start at disk 0. So in our mind that would be disk 1, but in ordinal numbering that's disk 0. Now then, if we want to go ahead and create a partition with a basic disk, we'll right-click on our unallocated space. Make sure that you do not right-click here on the disk itself, because that gives you a different shortcut menu or a different pop-up menu there. Instead, we'll right-click here and choose from this shortcut menu, New Partition, which starts the wizard. And much of what we do in Windows Server 2003 is driven by configuration wizards like you see here. Typically, the first screen is just an introduction. There's not really anything you do with it. You just click on Next so that you can actually start doing something. In this case, maybe we want to create a primary partition, and I'll click on Next. Notice that I could have also chosen an extended partition, and if I already had an extended partition, I could have worked with a logical drive as well. Anyway, we'll go ahead and click on Next, and we'll specify the size of the partition. I'll just make it 1,000 megabytes, which is about a gigabyte, and then we'll go ahead and click on Next. Then we can assign a drive letter, and I can use drive letter E, which is the next available drive letter, or any of these other drive letters you see available to us here. I can also mount it to an empty NTFS folder, which is what we would call a mounted volume. I'll talk about that later. And I can also just not assign any drive letter or path, which has very little usefulness. And we can go ahead and click Next and not format the partition at all, which again has very little usefulness because in order to store data on it, it has to be formatted. In this case, I'm going to keep everything NTFS, and that's typically the best way to go for terms of performance and security, as well as reliability. But you can also choose FAT or FAT32. And then I can choose the allocation unit size. By default, that's going to be 4 kilobytes on a drive of this size, but I could change it to something else if I wanted to. Typically, you don't need to do that unless you have a specific kind of file that you're going to be storing on this that makes better use of larger cluster sizes, for example, or larger unit sizes. Then we can choose a volume label. You don't have to put anything in there. I'll just put in data for the fun of it. And then we can also perform a quick format, which does not perform extensive error checking on the actual disk, and it's not normally necessary on today's disks, which are usually pretty reliable. We can also enable file and folder compression. Typically, that's not a good idea. It's usually a better idea to compress individual folders as you see the need, but later on we could go back to the disk or a folder or file if we want and manually perform compression. We'll go ahead and leave it at just perform quick format and click on Next and then Finish, at which point we see that it starts to perform its formatting function here. And as it does its formatting, and then it finishes that formatting, that disk is now available to store data. So that if I want to click on Start, right-click my computer, for example, and choose Open or Explore, I will now see that I have data, which is the volume label I gave it for drive E, and I can start to create files on this volume. Now then, to create an extended partition and logical drives within it, I'll just right-click here again on my remaining unallocated space, choose New Partition, and then I'll quickly go through the wizard here. I've got to create an extended partition, click Next. I can give it a partition size if I like. Let me just make this, 5,000 megabytes. And then we'll click Next and Finish. And then we just have this extended partition here designated with the darker green outline. You see the legend down here for extended partition. And then it's free space within that extended partition so that I can use it to create a new logical drive by, again, right-clicking and nexting through the wizard, where I have a logical drive option here. And then I'll choose which size I want it to be. 2,500 megabytes, for example. Again, I can give it a drive letter, and then I can format this just as I showed you earlier. Let me just say, backups or something like that for the volume label, and I can go ahead and perform the quick format again, and then Next and Finish. And now you'll see that I have a drive letter F, which is a logical drive, inside of this extended partition. Now let me also show you how you can create what's called a mounted volume. This will be very useful because I want to be able to access drive E, and I don't want to create additional drive letters. But what I do need is additional storage. So let's say that drive E, for example, has some files on it, meanings.doc and so forth, and drive E is starting to fill up. But I don't want to install another drive G or drive H or anything like that. Instead, what I want to do is to use additional space in computer management, where I've got my disk management console open here, and I want to use some of this free space over here. Well, what I can do is to create a logical drive, but instead of assigning it a drive letter, I will make it a mounted volume that points back to an empty folder on drive E, and it does have to be an empty folder. To do that, I'll right-click and choose New Logical Drive, and initially the wizard is the same thing that I did earlier, and I'll just go ahead and use all the available drive space there. This is where it changes. This time I'm going to mount in the following empty NTFS folder where I'll browse to drive E, and I'll create a new folder, and I'll just call this Overflow to make it intuitive here. And I'll click OK, and then I'll just click Next, where again I'll give it a volume label again, for example, of Overflow. And I'll quickly format this and click Next and Finish. And now what happens is, when I go to drive E, I see that I now have this disk-looking item here, which in its actual function performs like a folder, but it gives me a visual clue that this is a mounted volume, so that if I right-click on the contents of this and choose New Document of some kind, then I'll say, data, formats, documenters, or whatever I want to call this, and that is now stored actually on this volume here. However, it looks like it's stored on drive E. This is very useful, again, if you don't want to create additional drive letters and you want to make things easier for users to navigate instead of having to use additional drive letters. Alright then, so that's how we can go ahead and create some partitions with basic disks. What about dynamic disks? For these, we'll have to go to the disk itself, and here you'll right-click to convert it first to a dynamic disk, at which point you can then create volumes. So now we've gone ahead and right-clicked and choose Dynamic Disk, Convert to Dynamic Disk. It already selects Disk 2, which I had right-clicked on, so I'll click OK here. That's pretty much all there is to it. Now it's Dynamic Disk, and now I can create new volumes here, but they will be the Dynamic Disk types of volumes, which give you these options. For example, in this case, it gives me a simple volume choice, and that's the only choice because it sees that I've only got a single dynamic disk in this computer. If I had multiple dynamic disks, it would give me some of these other options as well. And we can go ahead and click on Next for the time being. Again, if I had additional disks, I could select them from the left, add them to the right, and then combine their size and specify a specific size out of the sum total of the disks available. If I had more disks available, and for this purpose, it would essentially become a spanned disk. In my case, I'll just say, 1,000 megabytes for about a gigabyte here. And then we'll go ahead and click on Next. And again, this is the same as what we've seen before. I'll just leave it at drive G. And then my volume label here, I'll just call this a simple volume, just for sake of being intuitive. And we'll quickly format this and then Next and Finish. And then once it's done that, we take a look at it, and it'll give us a new color here as well, a really fancy little mustard color, there it is, with a designation as a simple volume. Well, then we look at this, and maybe I'll say, oh, doggone it, I didn't mean to put 1,000 in. I meant to put 10,000 in. I wanted to use all 10 gigabytes. Well, now it's too late because I got users already putting data on here already, and it's going to be kind of awkward if I have to back up, restore, tell everyone to stay off the drive, all that kind of stuff. Wonder what else I could do. How about extending it? I'll just right-click here, choose Extend Volume, and guess what? It takes us through the Extend Volume wizard, and it gives us a very similar interface here. This time, all I have to do is to select the amount of disk space I want on this disk, and again, if there were other disks here, I could click Add and add their space in here as well, which would again make it more of a spanned disk at that point. In this case, I'll just use the remaining disk space that I've already got next and finish, and that's pretty much it. It retains the same drive letter. It's still considered a simple volume. It's just extended, and it's transparent that it's been extended to the users and to me most of the time, and it'll still be accessible the same way over the network and locally through drive letter G. In this nugget, we looked at disk management, and we saw the difference between a basic disk, which is probably what you're accustomed to working with if you've worked with computers in the past, and dynamic disks, which are new, starting with Windows 2000 and carried over into Windows Server 2003. Remember, a basic disk is what you use if you're going to create partitions, and the dynamic disk is what you use if you're going to create volumes. This gives you a lot more flexibility, but it might not be necessary to have a volume unless you have multiple disks in the same computer. And when you put those disks in the computer, when you first start the Logical Disk Manager service in the Disk Management Console, it'll initialize those disks through a wizard for you to put uniquely identifiable information on them. Very useful if you want to transport the disks to another computer, for example, and we'll cover that in our next nugget. We also got started creating logical volumes here, and we did some basics with that, and we'll cover that some more in our next nugget when we start to move into other topics such as RAID. I hope this has been informative for you, and I'd like to thank you for viewing.